Howdy everybody, welcome back to Auditing. In our video today we're going to be having a little fun with data analytics, and I'm going to take a moment to show you how to apply Benford's law to a data set in Excel. Now, you may not be familiar with Benford's law, and our book only mentions it in passing in a paragraph or two, and I've tried to give you some background information in the assignment link. And I'd like you to make sure you read through the background on Benford's law here. The basic idea behind Benford's law, if we look at a data set of naturally occurring data, like payment data, and you see I've got Clinton County, Ohio payment data up here for fiscal year 2022. In the spreadsheet are all the payments that they made in Clinton County to different vendors and different people. And you can see we got the check amounts right here, check number right there, but I'm looking at the amounts. And if we think about the first digit in these amounts, you can see 37, the first digit will be 3. 116.48, the first digit would be 1. If we just kind of think about that first digit, you might think, okay, well, the odds of that first digit being 1 would be 1 in 9. Obviously, the first digit can only be number 1 through number 9. If you look at the number 3, you might think, okay, well, the odds of the first digit being 3 would be 1 in 9. And now the odds would be the same for every digit 1 through 9 as far as being the first digit of a number. What Benford found out, though, the mathematician, he figured out that that's not the case. In a randomly occurring set of natural numbers, he found that the first digit would be 1 about 30.1% of the time. The first digit would be a 2, 17.6% of the time, all the way down to the number 9 only showing up as the first digit 4.6% of the time. So the distribution isn't even in that first digit. In a naturally occurring set of numbers, it's going to follow that distribution that Benford came up with. That may not be exact, but it's going to be in that ballpark. Now, that is for a naturally occurring set of numbers. Non-natural set of numbers would be things that men kind of just made up to organize information, like zip codes, all right? Maybe area codes. And those are limited data sets. Another example might be if we took everybody in Ohio and we put their height in a spreadsheet. Okay, well, obviously, nobody is going to be 9 foot tall, and probably not many people are going to be 1 foot tall. So that's not a naturally occurring set of data. Same with weight. If we put everybody's weight in the state of Ohio in a spreadsheet and try to do Benford's law, it wouldn't work because nobody's going to be 900 pounds, right? Most of your digits are going to start with a 1 or a 2, okay? So it works great on payment data because it is a naturally occurring set of numbers and it doesn't follow a kind of predefined numbering scheme like a zip code where there's only 5 numbers, and it also isn't kind of made up by humans. The payments are what they are. So the idea here from a fraud examination perspective is we can take a payment data set, do a Benford analysis on it, and it should follow this pattern right here. If we have someone maybe in the financial office who's embezzling money or making up fake payments to vendors, chances are they won't follow this distribution. They're not going to write a bunch of $100 checks. They're going to write $800, $900 checks, right? So we could take a month, we can take a year, run a Benford analysis on it, and hopefully maybe see if there's anything funny going on. Now, it's not foolproof. It's just another tool in our arsenal here. But with that being said, our goal for today is to show you all how to conduct a Benford analysis, because that's going to be your assignment. I'm going to give you all some data sets here, and you're going to pick one, and you're going to run a Benford on it and see if the data matches up with what Benford said it would. Alrighty, so here we have our data from Clinton County. Fiscal year 2022 payment data. I did not break into the Clinton County Courthouse in Wilmington under the darkness of night with a black ski mask at 2 in the morning and steal the data in some kind of a daring coup. No, I just downloaded it off the internet. A lot of municipalities and governmental entities will have basically what they call checkbooks online where you can see everything that they've spent, and you can download the data, you can play around with it. And that's where I got the Clinton County information right off their website from their kind of online checkbook government transparency initiative thing. And this is every transaction, every payment that was made by Clayton County in fiscal year 2022. Now, you can see I've got the payment amounts right there. And you can see they begin with 37. That one's 37 bucks, 25 bucks, 116. The first digits, are different as we go down through here. And our goal, step number one, is to try to isolate that first digit. All right. So I want to basically create a formula that pulls that 3 out, that pulls the 1, that pulls the 2, that pulls the 7, that pulls the 8. You get the idea. I want that first digit. It's not a very difficult formula. In fact, it's pretty simple to make that happen. What I'm going to do is zoom in here a little bit so we can see what we're doing. And I'm going to start right here. I'll give a little buffer there before column I. And I'm going to make my formula. My formula is going to be equal left. Literally, left. I want it to return the leftmost number. All right? And I only want one number. I just want the first number. So my formula is going to be equal left. Put up my bracket. And I'm going to be using that column, column G. And I'm going to do a little trick here. Because when you do your Benford analysis in Excel, chances are you're going to have thousands, maybe even hundreds of thousands of lines of data. And if you use your mouse and scroll down that way, it's going to take forever. So I've clicked on it. Now I'm going to hold 2 keys. I'm going to hold Control and Shift on my keyboard, Control and Shift, and I'm going to hit the down arrow. And what that's going to do is take me to the bottom of my data. Now, if I had a gap in there, like I had a blank row, it would stop at that, and you would have to kind of hit the down arrow twice. But all my data is together, so I can hold Control and Shift and hit my down arrow, and it will highlight that entire column. Now I can just go back up to the top and complete my formula. Left. And there's my reference right there for where I'm looking, and I want it to return 1 digit. If I did 2, it would return the 3 and the 7, or it would return the 1 and the 2. I just want 1 digit. I want the very first digit on the far left. There we go. Isn't that cool? Look at that. So here we go. I've isolated the first digit in every single payment. Now we can run Benford. All we have to do is kind of have Excel count up how many have a digit of 1, how many have a digit of 2, and so on. So I'm just going to go ahead and put that in. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right on. So now we need a little formula here to count. I need to count all the ones that have a 1. I need to count all the ones that have a 2. So our formula is going to be equal count if. Count it if it's a 1. Count it if it's a 2. So here we go. Again, I'm going to go back to my first digit here, use Control and Shift, and go all the way down to the bottom. Now I'm going to copy the formula. All right, so I need that to be relative. I need that to be absolute, I should say. Make it absolute. I'm going to hit F4, my keyboard shortcut. You'll notice it'll put a $ in front of the 2 parameters there. And then I'm going to hit comma. Oh, it messed it up, didn't it? Did it erase my reference there? It did, didn't it? Oh, dang you, Excel. We got to do that again. So let's try it one more time here. Now, highlight. Come back up. And then we'll do our absolute reference last. I'm going to click on I2. There we go. Now we're looking good. I'm not going to make L2 absolute because I want it to be relative. I'm going to copy the formula down through number 9 there. So I'm going to go ahead and hit enter, lock that in. Excel found 5,230 instances of number 1 being the first digit. I'm going to go ahead and copy my formula as I mentioned. And there we go. We can dress it up a little bit if we want to. Perfect. So, in Benford says that the number 1 digit being the leading digit would occur about 30% of the time, right? And so we can see the times that number 1 occurs as digit number 1, number 2 occurs as digit number 1, and so forth. So now we need to figure out some percentages here. I'm going to go ahead and do a little math and add up my totals. 17,141. So now the final step of our Benford is going to be to take each one of these and divide it by the total number of payments here. We'll say equal, divided by, make that an absolute reference so I can copy my formula down. And there we go. And if you thought Benford was an idiot, well, check this out. Oh, I don't need all that math. Let's not do that. Let's do that. There we go. Perfect. So, there it is. If I did a Benford here, I've found that the digit 1, the number 1, occurs as the first digit 30.5% of the time in these 17,000 payments. The digit number 2 occurs 18.5% of the time. Let's compare what we ran with the Benford distribution. Go back to our assignment instructions here. I've got the breakdown in Benford. Look at that. 30.5 compared to 30.1, 18.5 compared to 17.6, 11.9. Very, very close. It's wild. Look at the number 9. 4.5 compared to 4.6. Almost exactly fit Benford's law. That data set, completely random, natural occurring numbers, 17,000 of them, and it fit the pattern that Benford said it would. So what we're looking for in Benford analysis is we're looking for, when we do the math and we do the work, that it pretty much approximates the breakdown that Benford predicts. If we had somebody in the Clinton County fiscal offices there that maybe had fake vendors set up and was cutting fake checks and then embezzling that money, chances are the pattern wouldn't fall that way because they're making up non-random numbers, right? Chances are maybe the 8 would take a lot bigger percentage of the data, okay? So that's basically the idea behind Benford's law. What we're doing for the assignment is I want you to download a data set. I've provided a few for you from Cincinnati, from Clinton County. Don't use the data set that I used, even though I provided it. You can play with it to kind of practice, but these are the data sets I'd like you to use. Run a Benford's analysis and see, does the payment data, I tried to combine payment and data into one word, PATA. So efficient. But does the payment data match up with Benford's law? And, you know, maybe you have a data set at work. You could download it and try to run it on a data set at work if you want to. I'm just giving you a few examples here so you didn't have to dig around. You're more than welcome, if you can find payment data that has thousands of lines in it, to go use that data. Do a Benford's law. Kind of interesting. Like I said, just another tool in the auditor or fraud examiner's tool belt to see if there is potential embezzlement going on. It's not foolproof, but it's a great way to quickly get some information on the potential for malfeasance to be occurring. All right, that's it, gang. Benford's analysis. I enjoy showing you that and kind of walking you through Benford's analysis. Hope you find that tool interesting and can learn how to use it. And maybe one day you'll be able to bust a fraudster with it. Who knows? That's it for our video now. And we'll come back next time, talk more about sampling and audit sampling and how that works in the field. I hope to see you back here for those videos. Until next time, take care, everybody.